Mhm. Right, because they asked me to find length, I know I'm applying this formula, right? The square root of the x component squared plus the y component squared. So I know that for sure. How do I know that? Because they told me to find the length. For this question, it isn't as straightforward as the others, right? They didn't give you the vector and just say, oh, find the magnitude. For this question, it would be helpful to find a sketch. Let me find a sketch, to do a sketch, because you need to find out what exactly is the hypotenuse. What vector do you need to find the magnitude of? So yes, very helpful to do a sketch of this one. All right, that's all I'm telling you. You can try it now. So like I said, for this question, it would actually be helpful to do a sketch, right? So let me just go to the black screen. So they want you to find the length of the hypotenuse. They told you this is a triangle, right? And they want you to find the length of the hypotenuse. The problem is they gave you 3 position vectors. So let me use white. Hold on, people, let's check it. So they gave you 3 position vectors. They gave you O, R, O, S, O, T. And they told you that the vector OR is represented by 1, 1. So that's the column vector. This one is 3. Which one? Okay, 3 minus 1. And then they told you OT is 4, 4. So those are the 3 vectors they gave me, right? And they want me to find the length of the hypotenuse of this triangle. They told me RST is a triangle, right? The problem is I don't know which length is the hypotenuse. So you need to find that out first. That's why I said it's helpful if you do a sketch, right? You need to recall when I did position vectors. I told you that the position vector actually gives you the coordinates of a point. If they told me that OR has the column vector 1, 1, that means that a point R, the coordinates of the point R is 1, 1. Same thing for S. If the position vector OS is 3 minus 1, that means that the coordinate of this point S is 3 minus 1. And then OT, the coordinate of this point T is 4, 4. So we went through this when I was doing position vectors, right? Position vectors, you could actually find the coordinates of a point. So sketching this now, let me say this is 4 and up here is 4. So this point is T. Let me do S now. So I'll say this is 3, this is minus 1. So then S is around here. Then R, 1, 1. So it's around here, right? So if I connect these dots, this is what my triangle looks like. And if you look at the question, they also told you that this, so let me just label the other points. Let me use T, this is S, and this is R. And if you look back at the question, they also told you that the angle TRS is 90 degrees. So we know that this is a 90 degrees angle. And the line, well, the side of the triangle that's opposite to the right angle is always the hypotenuse. So that's why TS, let me just highlight it in orange. This line right here, TS, that is what we're finding the length of, right? So now we can move on. We know that we're trying to find the length or the modulus of TS. But there's a problem. They did not give me the vector TS. They gave me OR, OS, and OT. So how exactly do we find TS? Well, that's where addition of vectors come in. Good morning, Troy. And that's what we are doing. That's what we finished on Tuesday, right? Addition of vectors. If I want to find TS and I'm given these vectors right here, TS is the same as saying TO plus OS. So it should really have these things here, right? Do you understand that? This right here, TS is the same as going from TO to OS. If not, I could like draw a sketch to show you what that looks like. Are you good? Yes or no?
Yes, Miss, we're good.
Okay, thank you for answering. TO. Went through examples like these last class. They did not give me the vector TO, but they did give me OT. And on Tuesday, we said that the relationship between TO and OT, or any vectors like that, the example from last class was AO and OA. This right here, TO is the same as saying minus OT. That just tells me that TO is in the opposite direction of OT. So let's say this is OT. Oh my. Anyways, yeah, let's just, okay. OT, a vector going from the point O to T. If I say TO instead, that just means I'm going in the opposite direction. So instead of going from O to T, I'm going from T to O. And that's why we could say TO is the same as saying minus OT, right? That just means it's in the opposite direction. And then OS, well, that remained the same because they actually gave us that vector. Minus OT, so that's minus 4 plus OS is 3 minus 1. We said when we're adding vectors, we're adding the X components and the Y component. So let me just erase this. Minus 4 is the same as saying minus 4 minus 4. How did I do that? Well, if this is a minus sign here, and I'm multiplying it by the vector, I need to multiply both the X component and the Y component. So 4 by minus 1, well, we know this is minus 1, right? So 4 by minus 1 is minus 4. Same thing here, 4 by minus 1 is minus 4. Plus 3 minus 1. So remember, we did all this last class, right? When adding vectors, you're dealing with the X components and then the Y components. So X components, minus 4 plus 3, that's minus 1. Y components, minus 4 plus minus 1, that is minus 5. Now that I have, so this is TS, right? Now that I have the vector TS, which is the hypotenuse, that's not what they asked me for, right? They did not ask me for the vector. They asked me for the length, aka magnitude or modulus. And we know when finding the length of a vector, we have to apply the formula. And that formula states that the magnitude of a vector, so in this case, it's the magnitude of ST, is going to be equal to the square root of the X component squared plus the Y component squared. So remember, the vectors are always in the form XY, right? So this is X, the number on top is always X, and then the number below is always Y. So what I would substitute into this formula right here would be square root X, always the top number, so that's minus 1, squared plus Y, always the bottom number, that's minus 5 in this case, so minus 5 squared. Minus 1 squared is 1, minus 5 squared is 25. So that's 1 plus 25, which is going to be root 26 units. And that's the answer. The length of the hypotenuse, TS, is root 26 units. Are you okay with that? Yes. No. Maybe.
Yes, miss. I am fine, miss. I am fine. But is this the formula? Like we have to know that formula?
Yeah.
Oh, okay.
Whenever they ask you to find magnitude, or you might see length or modulus, this is always the formula you have to refer to. All right.
I got you.
So do number 4 for me, please. Let me just talk it out with you first. The position vectors OA and OB are 1, 2, and minus 3, 5. So OA is 1, 2, OB is minus 3, 5. P lies on AB such that PB is a quarter of AB. Find the coordinates of OP. So there's a lot going on here, but it's fine, right? OP, they want you to find OP, but if you notice here, they gave you OB, they gave you OA, gave you OB, and then they gave you information about PB, but they did not tell you anything about OP. That indicates that there's some type of vector addition or subtraction going on. So what does that mean? You need to take the information that you're given and rearrange it so that you could get the vector OP. Just like what I was doing just now, they gave me OR, OS, OT, but I needed to find TS. So what did I do? I took the information that they gave me and I rearranged it so that I could find the vector TS. That's what you need to do. Take the information that they gave you, rearrange it in order to find OP. Just wanted to state that, right? Go ahead.